Okay, so we're on example 2 of section 1.9, and then wants us to compare tables, equations, and graphs. So those are three ways to represent data, and they each have their strengths and weaknesses. Our situation is that we have two people. We have some dude named Will and some girl named Megan. And Will has already ran around the track 6 times before Megan comes along. So Megan comes along, Will has already run 6 laps. And then they start running together around the track. And wants us to represent the relationship between the number of laps Will ran and the number of laps that Megan ran in three different ways using tables, equations, and graphs. So let's do the table first. So this is the table part. So they kind of set it up for us. We have the number of laps that Megan ran and the number of laps that Will ran. So when by time Megan shows up, maybe she's a little lazy, she slept in, whatever. Will has already ran 6 laps when Megan ran 0. Okay, so then Megan comes and they start running. So if Megan runs 1 lap, Will has run 7 laps, and 2, and 8, and 3. And remember, if Megan ran 3 laps, Will has ran already 6 more than that. So that's 3 plus 6 equals 7, 8, 9. And you can see the pattern. So I'll just finish up the pattern here. 10, 11, 12, 13. Okay, so that's how we show the data using a table. And tables are useful for a lot of situations because we can quickly analyze certain data points. So say we know that Megan ran 5 laps, and we quickly want to know how many laps Will ran. So we just look at the table, we say, okay, she ran 5 laps, so Will ran 11 laps. So that's a good way of showing data. Another way is using a graph. So with a graph, let's see here. Let's make this bottom axis Megan. And let's make this side axis here Will. The amount of laps that Will ran. So when Megan runs 0 laps, Will has already ran 6. When she's run 1 lap, Will has already ran 7. Then we got 2 and 8. I'll skip to 4, 4 and 10. I'll skip to 8. We got 8. We don't even have a data point for Megan at 8. Now this is cool because we can see that the dots are going in a straight line here. This is called a linear equation. So let me draw a line through this real quick. So I'm start a line here and go through here. What's cool about this is that graphs can show the pattern for a really large amount of data. So even though that we don't have any data for Megan running at lap 12, right, she stops at 7, our table stops at 7, but we can still look at the graph, go to see if Megan ran 12 laps, go up here, and then we see that see if Megan ran 12, then Will ran 18 laps. So graphs are a really cool way to analyze data, and it's used everywhere in our world, and it's really important that you learn this to be successful. And the final way to represent this is using an equation. Equations are very, very important. It's the language that computers need to use in order to be able to run these situations. So if we look at this, let's let M equal Megan, and so we're defining our variables, let's let W equal Will. So we need the relationship between these two. So if we look at our table, we see that if Megan runs 0, then Will is 6 more than that. 6 plus 6 plus 6. You see the pattern, plus 6. So there's always a 6 difference between them. So the amount of laps that Will ran equals Megan's laps plus 6. So that's how you would write it in an equation. What's awesome about equations is that we can easily put any number in for Megan and quickly get a number out for Will. So let's say Megan and Will are just like insane. Like, let's say Megan ran 100 laps. So she runs 100 laps plus 6, then that means that Will ran 106 laps according to our situation. So that's the power of equations, tables, and graphs. They all show the same data, they just all individually have their own pros and cons. Okay, so let's go on to the final example, problem number 3.